Back to another statistics video. In this video, we are going to look at how we can use SALT, which is Cengage's statistics software, to help us find the confidence interval for the difference of two proportions. And this is the one that you saw in Khan Academy where they did everything by hand. I don't expect you to do everything by hand. Sometimes it's nice to see that, but this is how you would use the technology to do that. So Duncan's investigating if residents of a city support the construction of a new high school. He's curious about the difference of opinion between residents in the north and south parts of the city. He obtained separate random samples of voters from each region, and we have their results in a table. They're asking us to construct a 90% confidence interval. So I'm going to pull SALT up, and we're going to see how we can type all of this in there. So we're going to go to inferential statistics. We are doing a two sample proportion, and notice that they're saying that we want to do the proportion of the south minus the proportion of the north. That order is going to be important. You're going to get different intervals if you type it in differently. So the proportion of the south, we are looking at those who support the construction. And we're looking at that keyword right there, support. So for the south, we have 77 out of 140. And then we have 54 out of 120. We are doing a confidence interval, and we want it to be 90%. And then we're going to generate that result, and it's going to give us that lower bound and that upper bound. So you can see that lower bound and upper bound are the same things that we got, that they got in the Concademia video. So let's do one from our Webazon homework. So here's an example from our textbook. A random sample is selected from each of two populations in order to estimate the difference in two population proportions. The random sample from the first population has a sample size of N1 equals 494, and a sample proportion of P1 is equal to 0.188. The random sample from the second population has a sample size of 724 and a sample proportion of 0.113. We're going to use this information to find a 95% confidence interval. That's represented from P1 minus P2. So let's see if we can type in some information that we know here. And I am going to pull up a sheet of paper so I can write some information down. So we know N1 is equal to 494, and that proportion associated with that first population, or sorry, first sample is 0.188. And P2 hat is 0.113, and that's what they're telling us here. And that N2 is equal to 724. So in order to use SALT, we've got to have the number of successes and the number of trials. So we know the number of trials is 494, but we've got to figure out what this is going to be. So we're going to set up a little mini equation to solve that. So we have x over 494, and that's going to be equal to 0.188. And solving that is going to help us figure out what that x value is going to be. So how do we get x by itself? Well, we do the opposite. Instead of dividing, we're going to multiply. And I'm going to do that on my calculator off screen, just because I've got so much going on screen. So I got 0.188, and I'm going to multiply by 494, and that's going to give me 92.872. And so I'm going to round that because we can't have 0.872. Let's go up to 93. And then we're going to have to do the same kind of thing here. So we're going to set up a proportion. X over 724 is equal to 0.113. To get x by itself, we're going to take 0.113, multiply it by 724, and we're going to get 81.812. So let's round that up to 82. So there's our number of successes out of the number of trials, 724. So that's this information here. Let's call this X1 and X2. And then I've got 93 out of the 494 trials. And we are looking to be 95% confident. Generate a result. So here's our lower limit and upper limit. So what is this trying to tell us? It's telling us that we would be 95% confident that difference, and we're looking at that population difference between those two proportions would fall between 0.0335 and 0.1165.